Okay, please do the bell assignment on your own paper. Whenever you're finished, you may go to the board, write your problem, and please go through the answers with them. Go ahead and pause this, and we'll finish up after you're done going over the bell assignment. What we're talking about today is Lesson 63, Solving Systems of Linear Equations by Elimination. And I'm just going to be honest with you, I don't particularly care to be gone on a day that we're talking about this, but it's just the way that it worked out for us. So bear with me, take good notes. If you need it paused, ask for it to be paused. If you need more explanation, ask for it to be paused and have more explanation, okay? Because you're not in here for me to see the confused look on your faces whenever you don't understand. So please ask questions if you need to ask questions. We've talked about two different ways so far to solve systems of equations. And the first way was solving by graphing. And that's where we found out whenever we graphed two equations, the point that they meet is their solution. Then we talked about solving equations by substitution, where we would get one variable by itself and we would substitute it in for the other, or for itself in the other equation. Today what we're going to talk about is solving by elimination. And whenever we do this, we're going to completely eliminate one variable, solve for that variable, and then plug it in. So I'm going to give you some examples here. Please do your best to follow along. Whenever we do this, we always want to set up our equations in standard form. Standard form, remember, is ax plus by equals c, where a, b, and c are all constants or numbers. So as you can see, these are already set up. Ax plus by equals c. These are all constants. Okay? So whenever we do this, we want to make sure that we have it set up in the right format. For us to eliminate a variable, we have to have opposite coefficients for one of the variables. So for x, I have a coefficient of 3, okay, a coefficient of 3 and a coefficient of 6. Those are not opposites. Then for y, I have positive 7 and negative 7. Those are opposites. 2 and negative 2 would be opposites. 10 and negative 10 would be opposites, okay? We want it to have the same absolute value, opposite signs. So what we're going to do is we're just going to add these equations the way that they are. So I have 16 plus 11 is going to give me 27 equals 7y minus 7y will cancel out. Then I have 3x plus 6x is 9x. To get x by itself, I'm going to divide by 9 on each side. 9's will cancel, leaving me with x equals 3. Now that I know that x equals 3, I'm going to plug it into an original equation. So I have 3. Instead of x, I will substitute 3 plus 7, y equals 16. I hope that you're all with me at this point. If not, please stop and ask questions. Now, I'm just going to work the equation. So I have 3 times 3 gives me 9. Bring everything else straight down. I want to get y by itself, so I'm going to subtract 9. What I do to one side, I must do to the other. 9's will cancel, leaving me with 7y equals 7. To get y by itself, I divide by 7 on each side. 7's cancel, y equals, these 7's cancel to a 1, so y equals 1. My solution to the system then is the coordinate 3, 1. Remember, we always want it x, y. Okay, final answer. That's it. The next example wants us to solve the system by elimination. Here, again, we are already set up in our ax plus by equals c. We're already there. Now, do I have any coefficients with my variables that are opposites? I have negative 2 and negative 2. Those aren't opposites. Those are the same. I have positive 2 and negative 7. Those are just completely different numbers. So what we're going to do this time is we're going to multiply one equation to get an opposite. So the easiest one to do here would be this -2 and -2. If we could turn -2 into +2, we would have opposite coefficients. So -2 times what is going to give me a +2? That would be -2 times a -1. And when I do that, I take it to everything. I have to multiply it by everything in that equation. So -1 times -2x is going to give me a +2x. -1 times 2y gives me -2y. And then -1 times 18 is -18. Now I have opposite coefficients. I have -2 and 2. Those are opposites. So I'm going to just combine my equations. So I have 9 minus 18 is -9. -7 minus 2y, or -7y minus 2y is -9y. And my x's will cancel because -2x plus 2x cancels. To get y by itself, I'm going to divide by -9 on each side. So my y's will cancel. -9 divided by -9 is 1. Now that I know what y is, I'm going to plug it into the original. So I'm just going to plug it into the top equation. -2x plus 2, instead of y, I'm going to put 1 equals 18. 2 times 1 is 2, and I'm going to bring everything else straight down. Now I want to get x by itself, so I'm going to subtract 2 from both sides. Cancels. I have -2x equals 16. To get x by itself, I divide by -2. What I do to one side, I must do to the other. So I have x equals -8. So my solution to the system is going to be the coordinate -8, 1. Final answer. Okay, here I have a problem to start with because I do not have two equations that are in standard form. My first equation is, my second equation is not. So to change that, I'm going to have to add 2y to both sides. When I do that, this one will cancel. So I will have 5x plus 2y equals 6. That +6 is what's left on the right hand side. So I'm going to go ahead and stack my second equation right under this so I can get ready to work. Do I have opposite coefficients for either of my variables? I have 5x and 3x. Those are just different numbers. I have 2x and -6x. Once again, just different numbers. So I'm going to have to multiply by something. For my y's, I already have one that's a positive and one that's a negative. So I would just have to multiply by something to make them the same. So I have 2 and I have 6. 2 times 3 will give me that +6, which will give me my opposite coefficient. So I'm going to multiply the whole top by 3. And when I do that, I have to take it to everything. So I will then have 3 times 5x is 15x plus 2 times 3, or 2y times 3 is 6y equals 3 times 6 is 18. Now I can combine them. So I have 18 and 18 gives me 36. -6y plus 6y cancels. 3x plus 15x gives me 18x. To get x by itself, I must divide by, not divide by 2, divide by 18 on both sides. And when I do that, I will get that x equals 2. Now I'm going to take that x, I'm going to plug it into my original equation. So I have 3, instead of x, I will put 2 minus 6y equals 18. 3 times 2 is 6 minus 6y equals 18. To get y by itself, I must first subtract 6 from both sides. Cancels. I have -6y equals 12. Now to get y by itself, I'm going to divide by -6. What I do to one side, I must do to the other. cancels, so I have that y equals a negative 2. So my final answer, my solution to the system, is going to be 2, negative 2. Solve the system of linear equations. Do I have both equations in standard form? Yes. Now, do I have two coefficients that are opposites? I have 2 and negative 5 with my x. I have 2 and negative 3 with my y. So, neither of those are opposites. Is there anything that I can multiply really easily to change it? Is there anything I can take 2 times to get negative 5? I need it to be just an integer. I don't have anything. I can't take 2 times anything to get 3. So I'm going to have to multiply both equations this time. So on the top, we'll say this time that we're going to cancel out our x. So to get, what I'm going to do here is I'm going to multiply by 5 on the top and 2 on the bottom. My signs are already opposites. The top one is a positive, the bottom one is a negative. When I take 5 times 2x, I'm going to get positive 10x. And when I take 2 times negative 5x, I'm going to get negative 10x. Okay? So now I'm going to take that 5 to everything in my first equation and my 2 to everything in my second equation. So I have 5 times 2x is 10x plus 5 times 2y is 10y equals 5 times negative 8 is negative 40. Then I have 2 times negative 5x, which is going to give me a negative 10x. 2 times negative 3y gives me negative 6y. And that's going to equal 2 times 14, which gives me 28. Now I'm going to combine my two equations. So negative 40 plus 28 is going to give me a negative 12. 10y minus 6y gives me 4y. And 10x minus 10x cancels out. To get y by itself, I must divide by 3 on both sides. Not by 3, gosh darn it, I'm giving you the answer. I must divide by 4 on both sides. And then I have y equals negative 3. So I can take that negative 3 and substitute it in to an original equation for y. So I have 2x plus 2. Instead of y, I'm going to put negative 3 equals a negative 8. Now I have 2 times negative 3 gives me a negative 6. I'm going to bring everything else straight down. Whoops. Well, I guess I can go ahead and put that. And then 2x. I have double signs here. They are opposites. Remember, opposite signs give me a negative. So I have 2x minus 6 equals negative 8. To get x by itself, I must first add 6 to both sides. Cancels. I have 2x equals negative 2. To get x by itself, I will divide by 2 on both sides. So I have that x equals negative 1. So my solution to the system is the coordinate negative 1, negative 3. Final answer. Last example. I hope that you are bearing with me here. I hope that you're understanding. And I hope if you're not understanding that you are asking questions. Okay? Example 5 says, a museum sells 280 tickets in one day for a special exhibit. A regular ticket costs $20 and a student ticket costs $14.50. How many student tickets did the museum sell if it made $4,918? So I'm going to have to set up two equations. Go figure. First of all, they tell me that they sell 280 tickets and that they sell regular tickets and student tickets. Okay? So I know that the regular tickets plus the student tickets has to equal 280 total tickets. Okay? That's how many were sold. They also tell me that a regular ticket is $20, a student ticket is $14.50, and they sold a total of $4,918 worth of tickets. So, regular tickets being $20, I can represent that by saying 20R plus 14.5S equals that 4,918. So now, for me to get a variable that's going to cancel, the one that I want to do because because it's easier in my mind is the R, because it'll be easier to do it without having a decimal. It'll just be an even number. So I'm going to take the top one, the top equation, and for the 20R to cancel, I must have negative 20R in the top. So I'm going to multiply by negative 20 in the entire equation on the top. So when I do that, I will have negative 20R minus 20S equals 280 times a negative 20, which gives me negative 5,600. Now that I'm here, I can combine my equations. So I have 4,918 minus 5,600 is going to give me negative 682. Bring down my equal sign. Then I have 14.5 minus 20 is going to give me a negative 5.5s. And my 20r minus 20r will cancel. To get s by itself, I'm going to divide by a negative 5.5 on both sides. Cancels. So I'm left with s equals, and it's negative 682 divided by negative 5.5. So I get 124, and S represents student tickets. So it wants to know how many student tickets the museum sold. Well, we already found that, so we don't even have to plug it back in. Final answer. So for your homework today, it's going to be from lesson 63. It's not what's on the board, you know that. Okay, so it's going to be lesson 63. We will do A through E, 1 through 5, and 15 through 29 odd. Whoops. Okay. Please make sure this gets written on the whiteboard and on the little board, so if people miss, they know what they're supposed to be doing. Be good. Make sure you have this done by tomorrow. That's when it's going to be due. No talking. Get working. If you have questions, I am sure that Mr. Woods or Mr. May will be more than capable of helping you.